All right. Well, thank you all so much for joining. I'm really, really honored to be invited to take part in this group. I've been kind of watching from afar for a while and seeing all of the cool sessions you guys have done and all of the amazing work you've done. I mean, I feel like this is one of the coolest groups anywhere in the world doing this kind of stuff. So I'm really glad to get to come and speak with you all. And I'm especially excited to tell you a little bit about Hypar, which is the company that I work for and the product that we're making, and introduce it to you and show you also, show you how it works as kind of a tool, but also show you how to develop functions on Hypar and how to use it as a way to publish your own computational tools on the web. So some of you may already know some of this stuff, but I thought it would be good to explain a little bit about what Hypar is and show you some examples. We refer to Hypar as a next generation platform for designing, generating, and sharing building systems and building logic. So we have designed it to make computational intelligence and generative design accessible to the entire industry. Oftentimes, I think existing computational platforms can be just the domain of a very small specialist group. And we want to make it so that we can support both specialists and everyday users and have everybody get the benefit of computational design. And a big piece of that is making it easy to share, reuse, and recombine tools, processes, and workflows. So I know, my background is in architecture. I worked as an architectural designer for a number of years before becoming more of a software developer. And the thing that I always found was that, I would spend a lot of effort and energy building computational tools in Grasshopper and Dynamo. And even though I tried to make them as accessible as possible, I would share them with my colleagues, and it was always difficult to get other people to use the tools. It was like, despite my best efforts, oftentimes it was me or a fellow, expert needing to run the tools, and people were, I think, a little scared to use them themselves. So we are aiming to make it really easy to build tools and make them accessible and available to just about anyone. And we are committed to kind of modern cloud technologies and open standards. So we have done, Hypar itself is not open source, but we are built on a number of open standards. Some of our own, like our core BIM representation, which I'll talk about a little later, is in fact open source. And our CTO worked on the Revit team, but also was at Google for many years. So he's been leading us towards, sort of very, very modern ways of thinking about how software can work on the cloud. So one of the things we say a lot on the Hypar team is we want to end blank sheets. We don't want if you probably recognize the sort of empty starter Revit project. And, I think this is sort of a stand-in for a more complex reality, which is that, every design project we do as architects begins with this kind of blank sheet. And, you probably have libraries of scripts and standards and content libraries and all of this stuff. But when it comes to actually doing the design, you always start from square one. You kind of, you begin with this empty page. And at the same time, there's this proliferation of incredible computational intelligence all over the world, all over the web. People are building tools to do similar things. The sort of canonical early example is the Stadium Bowl generator. It's a really good thing that you can tie together structural considerations and human experience and parametric models and make something where everything gels together. And so we see this explosion of these tools, and yet we keep seeing more and more of these. And I think there's a there's a good reason for this, but there's also a reason that I think is more of a bad thing. I think the good reason for this, why people keep writing these tools, is that they're creative and inventive, and they come up with lots of different ways of thinking about the same problem. So they're not, your stadium bowl generator is going to think about the problem differently than mine. But I think the potentially bad reason for this is that on the whole, it is much harder to use other people's tools than it is to just go ahead and build your own from scratch. It is so often the case that, oh, I found this cool script on the web and I want to pull it into my project and use it. And then you open it and you're like, wait, how does this work? Like, oh, I don't have the right plugin, or oh, it doesn't work on my computer, or there's a DLL conflict, or it's not documented very well, or it uses a different way of representing the data than I'm used to. And I think we've all encountered this in our professional lives. The intelligence is out there and people are willing to share it freely, but the challenge of actually taking advantage of it is really great. And, I think over the course of my career, I've moved from being, more of a designer to more of a software developer. And as I've learned more about, kind of professional software development, it's clear to me that software engineering has some solutions to problems like this. In software, programmers don't write every application from scratch. They'll use a package manager to pull in other people's code. You can just go and get a library for dealing with dates and times, or a library for doing this, and it's fairly easy to fold it into your existing code base. And in fact, this is very much true of the Hypar application itself. This is actually a tree map of the code for Hypar's web application, and the areas in red are our code, the code that we wrote, and all the rest are third-party libraries. I mean, you all probably know a lot of this, but this is really how modern software is built. We rely on freely available open libraries, this incredible accessible body of knowledge. And the effect that this has on the industry is that it empowers everyone to build better and smarter applications without having to start from scratch. I don't have to worry about figuring out how to represent dates and times because I know there's a library I can pull. So, and the special sauce, the thing that's yours, is what makes Hypar different than Pinterest. It is your creative orchestration of all of these different moving parts. So I don't think this takes away the idea that things can be very different and identifiable. So one of the core ideas of Hypar is, what would architecture look like if you could just utilize someone else's stadium bowl generator on your project? If you could just pull in a package or a function which has some notion of how a piece or a system in a building is designed, and use it yourself. So this is an example of doing that in the Hypar interface. So I can construct a workflow, and I have access to this huge library of functions, and I can just search for stadium, and I can find a stadium bowl generator, and I can quickly add this to my project. I can take advantage of the logic that someone else has written, and they have exposed a number of parametric controls for this logic. So I can play with that interface, but I don't have to know anything about how this is written. All that's available to me is the sort of front interface, like what are the parameters that I can control, and do I need to know in order to manipulate this to my purposes? And so what we hope is that over the next couple years, we will build up. I mean, we already have an incredible community of contributors, but we want to see an explosion of contributions where people are adding their logic for building systems onto the Hypar cloud so that the industry can actually move forward. It's a big and ambitious goal, but we want to enable this kind of bootstrapping effect that the software industry has already seen, where the basic logic of a parametric model is just already there for you to use and recombine and plug in any way you see fit. You don't have to start with points and lines and vectors and masses and B-reps and build up from these very low level concepts. So one of the things that underlies all of this is what we call elements. Elements, we refer to as the smallest useful BIM, but it's basically a library and a data standard for representing BIM systems. So BIM elements, beams, floors, columns, levels, whatever, can be represented as Hypar elements. And these are really just bundles of geometry and data. So I can, and one of the core ideas here is that, you know, a piece of software like Revit comes out of the box with a lot of these ideas. You know, there's a thing called a column and there's a thing called a wall. But oftentimes we run into a thing we need to represent that Revit doesn't have an element type for. Or there's some complex compound concept, which is like, you know, a space with a particular name and a particular type of furniture associated with it. We kind of run up against limits when we work with the vocabulary that Revit provides for us. So elements allows you to add your own types as you see fit. You don't even have to contribute back to the code base in order to add new structured data types that can represent building elements, geometry, and data. So one of the best things about elements is that it is open source and extensible. You can go to the elements repository and you can see all of the code. And it is both this kind of representational system, a way of, you know, building up classes that represent elements, but it's also a pretty bare bones geometry library. And you might ask, why would you build another geometry library? There are so many geometry libraries out there. There's, you know, there's Rhino Common and there are all of these things, but it was really important to us that we have a library that was open source, that was lightweight, because we want to be able to run it on modern computational infrastructure. So that means being able to deploy it to cloud microservices and being able to run it on Unix and things like that. So we did not find an existing system that satisfied all of our needs. We also, for the representational piece, we looked at systems like IFC, which are great. IFC is amazing. It's this incredible standard for representing building elements in an interoperable way, but it's not lightweight and it's very hard to extend, and support for it is incomplete in even the most, you know, even the biggest applications like Revit. You know, the number of times I've heard, oh, this IFC element didn't translate correctly when I pulled it into Revit. You know, this is reality, and making changes to that is often out of the hands of even competent developers working locally. So we wanted to set out to create a library that would allow a kind of flexible growth over time, and enable a kind of rich description of building elements, as well as the tools to work with them, to do things like, you know, intersections and ray casting and polylines and polygons and offsets and intersections and all that good stuff. So the next concept that underlies Hypar is the idea of a function. So a function is how Hypar represents the logic of some building system. So you might have a function that represents the structural system for the building. In particular, it represents a strategy, one way of thinking about producing the structure for a building. So these functions are kind of like a Grasshopper component or a Dynamo component in that they have inputs and outputs and some computational logic, but typically they're higher level than those things. Typically they represent an entire building system in their logic, but they also share that they have inputs. You know, there are variables that you can set which drive that function. You can also specify model dependencies. So you can say my function, my structure function, needs to have access to the envelope and the levels in the model so it can calculate what it needs. And similarly, it can produce new elements that go back into the model, and some additional function can consume those beams and columns and do other things with them. You can also produce data outputs. So numbers or text or reporting or analysis values, which tell you something about the system, like, how well is it performing, or, what's the total mass of the structure, or whatever other values you'd like to produce. And the thing that's powerful about this is that because we're explicit in defining these are the things that I need as a function, and these are the things that I produce, we can pull all of these functions together into a Hypar workflow and have them connect automatically. So I don't have to drag a wire to pull the levels from this part over to here. This function needs the levels, so it goes and gets the levels automatically. And this is another one of the kind of core ideas of Hypar, that you shouldn't have to think a whole lot about how you wire things together. The logic of the function should tell you enough that you can just throw them all together and they'll automatically connect. So I'll show you an example of that in operation. The other thing that this enables is, if I decide that I don't like the logic of the envelope in this particular model, I can just swap it out for another one. And, I don't have to disconnect a bunch of things and go reconfigure how the data works. I can just pull that one out and plug this one in, and everything works. So I'm going to show another video, a few more little videos, and then we can get to some live examples. So here's an example of a workflow where I'm manipulating the parameters of a curtain wall function, and I'm setting, this is what I want my spandrel width to be, and these are the material settings, and I'm getting live data readouts about what's the percentage that's glazed for energy calculations, and I can remove the massing logic and plug in a different one. So previously I had been doing these sort of centerline masses, but now I want to be able to draw a shape as the kind of basis for this mass. Another core idea of Hypar that I think is really important is that it's a computational environment, but it's also a modeling environment. And so I can just get in here and model the thing that I want, because we know that the automatic solution is never going to completely solve the problem. There are always going to be cases where you just want to get in there and indicate your intention by drawing or drafting. So I just plugged in a new envelope, and everything else has cascaded downstream. The other thing is that we believe that every project wants its own customized design environment where you can view the data that matters to you for this particular project or process. So we allow you to customize the environment quite a lot and build dashboards and other sorts of data visualization that are directly connected to your project to see the things that matter to you as you're making design decisions. Because all of this is on the cloud, it also means that it's accessible from anywhere, from any device. I can pull this up on my phone or on my tablet, and I can interact with it. And, even if it doesn't have very much computational power, because everything happens in the cloud, I can make changes, I can edit, I can even sketch things and have them update to the workflow. And so I'm carrying around, in my pocket, all of the computational power of this complete parametric model. This also enables sharing with collaborators or clients. You can say, I'm just going to send you a link to this, and they don't need to have a copy of Grasshopper, or they don't need to install anything in order to interact with the parametric logic of your model. And a lot of the examples I've shown have been about early stage conceptual modeling, but we're really interested in going into fine detail too. So we're working with a lot of construction companies and building product manufacturers to get their products and their building systems plugged into Hypar as functions. You may go to a manufacturer and get their Revit families, and often that content is maybe not very good, but that's also because it's just dumb content. It doesn't really encapsulate how the system works. It's just what the system looks like. And so we want to encourage product manufacturers to build both what the stuff looks like that they produce and how it works, how it plugs together, how it incorporates with the other systems in your building design. So, you know, we want to support, you know, if you want to do a structural system on your building, you know, maybe instead of just making your best guess as an architect, maybe you can rely on your structural engineer's function that generates that stuff for you. And we also know that firms have already invested a whole lot of time and energy into building custom tools. And those are in C#, in Grasshopper. So we support those as languages for functions. You can take your existing Grasshopper script and put it up on Hypar as a function, and it can just play with all of these other functions. You can, you know, you won't be able to utilize the Revit API, but you can take the core of your C# code and make a function and publish it to Hypar. You can even take an Excel spreadsheet that's maybe just about tabulations or calculations that you want to do on model elements, and you can make that a function too, because we know that a lot of intelligence at firms lives in these spreadsheets. So one of our missions is to support taking your expertise and your intelligence wherever it lives and making it possible to put it in one place and make all of those things talk to each other. Finally, we also know that for Hypar to be a practical tool for people to be able to use it today, you know, you'll have to be able to use it in context with your existing tools. So we've enabled translations to and from Revit elements and Hypar elements. So you can take your Revit model, stream it into Hypar, do stuff with it, and stream those results right back. So you can see this is actually a function or a workflow operating live, and it's streaming its results back into Revit. So if I make a change in Hypar, I can visualize that result in Revit dynamically. And this is sort of a preview mode, but there's also a way to basically bake that geometry back into Revit as well as real native elements. And one of the things that's really cool about this is that it's totally customizable. So if you can write a little bit of C#, you can write totally custom converters. So you can say, you know, in my firm, we model with this particular modeling standard, and we use these parameters to mean these important things. And they, you know, without those things, it doesn't work for our process. So you can write your own converters that translate to and from Hypar elements and incorporate all of that key information. You can totally customize, how do I turn a floor into a Revit floor? Or what families do I want to represent the stuff that I'm modeling computationally in Hypar? The other thing that's coming, which I don't have a great example of, is we're enabling the extraction of Revit content. So you'll be able to take like a content library, a bunch of furniture families, let's say, and publish those to Hypar, do computational modeling that positions those and visualizes them in rich 3D. And then when you're done and you want to pull those back into Revit, it will reinstantiate the correct families in the right locations with all the right parameters set. So to summarize, I think, you know, we I think at this moment are often perceived as a kind of expert tool for developers, but we are really aiming to be a tool that supports designers of all stripes. So for designers, we want Hypar to be the place where you have highly customizable design environments, where you can take advantage of the power of computation without writing a lot of your own code, where you can interoperate with existing tools without too much extra effort, and where you can quickly iterate on design. And then on the other hand, for developers, we really want to be the infrastructure that allows you to build up something really sophisticated without having to spin up your own AWS infrastructure or publish a web app on your own. I mean, I think the people in this group, many of you may actually be capable of those things, but that skill set is not common in the industry. And so what we want is for the the sort of amazing group of designer developers who know about how buildings work and know about how software works to just focus on the stuff that matters, which is building that logic, building the computational logic for a building system, and not have to worry about, oh, how am I going to host it? How am I going to make it scalable? How am I going to manage user permissions? How am I going to share it to people without exposing my code? How am I going to enforce security? How am I going to build a developer environment where I can quickly iterate on this logic and visualize those things? So Hypar is designed to enable all of that stuff so that you can focus on what matters, which is the actual ideas and logic and expertise that go into a parametric building system. So that's the kind of first portion. That's the kind of big high-level overview. And I think I'd like to just do a kind of live demo of the platform, and then maybe we can stop for a minute for some questions. Cool. So I'm going to log into Hypar. I should mention that Hypar is currently free, so everything I've shown you, you can do for free. We will probably be moving to, actually, let me log in with another user. Everything I've shown you so far, you can have access to today for free, but we will be moving to a sort of subscription-based model probably in the next couple months. But we intend to always offer a generous free tier. So you should always be able to do something useful on Hypar for free. And we want to reward folks who are contributors to the platform too, and make sure that they're able to get something out of it, maybe without paying for a subscription. We want the folks who are actually doing real work, who are building, designing buildings on Hypar, to get a subscription. And that can be from an individual subscription all the way up to like a company enterprise subscription, but we're still working out those details. So if I want to design a building, I might start with some context. I'll go grab this location function and add it to the workflow. And I'll pick a location. I'll pick New York because I am most familiar with it. That's where I'm based. And I can just sort of zoom in on a site. Let's pick this one. And this function is using Mapbox's data to pull in maps and 3D geometry. So I get a map right off the bat, and I can also create 3D topography and 3D buildings if I want, which I can use to do like analysis downstream. And I can then continue to add functions to this workflow. So while that loads, maybe I'll create an envelope by center lines. So I've loaded in my 3D context. And if I want, I can just sort of draw a little line that'll be the basis for my project. I'll hit save. And I can, that looks a little dinky. I probably want it a little bit higher. Let's see if we can make it 200 meters. And maybe I want it a little wider. And maybe I want to add another mass that kind of intersects it over here. So I'll add another center line. It goes like this. And I'll make that one even higher. Or actually, let's do like 80. So it's created this mass for me. And maybe I want to add some floors. So I'm going to add floors by levels. And then the thing that we see right away is that it's actually telling me as the user that it's missing a dependency. So this is that idea that a function exposes what it needs and what it makes. And the floors by levels function is telling me I can't make any levels, or I can't make any floors because I need levels. And if I click this, it'll show me all of the different ways that I could create levels that would satisfy this dependency. So I'm just going to use this simple one. And I can control the parameters of this. Maybe for a quick early stage sketch, I don't even need this. Maybe I don't need to tweak the parameters. I can just use the defaults. But later on, I can go back in and I can manipulate those defaults. Let's add a facade grid, maybe. So let's do a facade grid by column grid. And I'm going to run into this scenario again where it needs a column grid in order to execute. So let's use one that's based on the perimeter. And this is going to create a column grid based on the geometry that I've created. And then it's going to create a facade grid for me. And let's just hide the envelope as well so we can see what we're working with. So it's done some version of this, but there are lots of different ways that I might take advantage of this. And I can tweak the minimum panel width. So maybe I want to omit panels that are too small. Or maybe I don't even like this pattern. Well, let's go with this one for now, and then I'll swap it out for something in a little bit. So let's put a curtain wall on this. I'll drop this in, and it will take that facade grid and turn it into a bunch of, unitized curtain panels. And maybe I want some vertical spandrel as well. Maybe I want there to be like a little vertical element in this curtain wall. And maybe I want to change the color. Maybe I want it to be a bluer sort of a glass. And I want my spandrels to be a kind of dark color. And my mullions will be dark too. So the other thing that's nice about this being all executed on the cloud is that, unlike a lot of computational modeling environments, it's non-blocking. Like, I can continue to interact and play and tweak things. I don't have to wait for it to finish solving because that solving is happening elsewhere. Maybe I'll introduce a couple internal mullions and I'll give a nice kind of gridded effect. And, maybe I don't actually like the way that it's done this curtain grid. Maybe I'll swap it out for a different facade grid that can do more sophisticated things like patterns. So maybe I'll use a fixed width of 3 meters, and I'll do a little height shift, so I'll get kind of a staggered effect. So now it's going to give me a different result, and I can just kind of quickly try out all of these different ideas. The other thing that, so yeah, maybe I like that. That's kind of a nice effect. The other thing that is built into Hypar that you as a developer don't ever have to worry about is that any input parameter, you can say, I don't really know what I want the value for the column spacing to be. So let's sample range. And what it'll do is take the numerical range of the whole slider, and I can constrain it and generate a bunch of alternatives for me. So it's going to come up with 20 different options along this spacing, and I can scroll through and say, well, let's try this one. Or maybe I can even visualize what those results are. So we can try it with 4 meters, we can try it with 20 meters, and this is going to recalculate those values for me. So it can be really useful when you're doing design studies to just sort of quickly try out alternatives. Actually, before I leave this one, let's also add in a view analysis. So I can just drop in a view radius function. I can set the height where I want it to be tested. I can set a max radius. I'll drop it down for this one just because this is a pretty heavy model. And so functions can represent building elements like, curtain walls, but they can also represent analysis results. So I could do my energy analysis or my solar analysis or my view analysis and just have that be incorporated in the project. And that means that other functions can take advantage of those results and use those as inputs and say, maybe I want to change the facade on the basis of this view analysis. That's the kind of vision of Hypar as a platform. It's been really exciting to see the function library continue to grow. New functions are getting added every day, but I would love to see it continue to expand and grow as we get more and more users taking advantage of the platform. So in the next section, I want to show you actually how to write Hypar functions, both using Grasshopper and using C#. But I think now would probably be a good time to open it up for some questions.
Thank you for the amazing presentation. Then, okay. 誰か質問などありますか？感想など質問ありますか？ Sorry for talking in Japanese. すみません、堀川さん、お願いします。
Well, thank you for the presentation. Everything looks really magical.
Yeah.
I can't really believe that this is all possible in the cloud. So, one question I would have it, I'm usually using Grasshopper for my main tools, and I'm wondering when we create the functions, and do we need to be focusing, do we need to use some kind of Hypar based API, or could we just use the model, the modeling stuff that we have built previously in Grasshopper and then use it right away in Hypar? Is that possible?
So any built-in components to Grasshopper you will be able to use. So if you want to do your BREP intersections and all of that geometry stuff is accessible in a Grasshopper Hypar function. There is also a Hypar library for Grasshopper, which is what allows you to say, these are the things that I want to treat as inputs. These are the things I want to treat as outputs. This is where I pull in Hypar elements and get information back out of them in the Grasshopper context. And this is how I produce new Hypar elements. I'll show all of that in a little bit, but the basic answer to the question is anything here you can use. And we support a handful of plugins. They're mostly plugins that I've written, but we also support a few others. And I think the way that we're going to have this work, this isn't totally decided yet, but my impression is that for enterprise customers, we will allow adding other plugins. So if you really need to use, Parakeet, let's say, in your workflows, you can do that. We'll set up a custom system for you that has support for that plugin. But until then, so regular users will probably only be able to use the plugins that we support officially, which are right now.
I see.
There is some mesh tools and some of the stuff that I've written and some other random things.
Is it possible to use like C# component or Python component to write your own script?
Great question. So currently we don't do that. And it is technically possible, but it is currently prohibited for security reasons because, this stuff is happening on our servers and we know what happens with all of the built-in components and we know what happens with all the components that I've written. But if you could write any old C# script, there's a chance you could gain access to someone else's data, and we don't want to support that currently. I see. However, this is another one of those things where for an enterprise customer where we could create a sandboxed environment, we could probably support using the scripting components in that way.
I see. Well, still, it looks amazing. We really would like to try this out.
ありがとうございます。他に誰かいらっしゃいますか？何かコメントなど。
I have a question. So thank you for the great introduction. Is it possible to bake the geometry into Rhino or Revit or Sketchup or any other 3D software after using this?
Yes, so that's a great question. In Revit, you can absolutely produce native Revit elements with this. At the moment, you might need to write a few custom converters just because we haven't built in support for every imaginable Revit element type yet, but that's, that will come eventually. But you can also download your current workflow as IFC. So that's one way to get stuff into Revit as well. And then as far as the Rhino context, currently the only thing that's supported is using Grasshopper to get that stuff out. But if let me make a simple example where I just use the floors, just because this will go quicker if I do it like this. If I have the floors visible here and I export as a JSON, I'll be able to download a representation of this model, which is in Hypar's own sort of elements data representation. And then I can take this, and in a Grasshopper context, I can take that JSON file and I can say, okay, give me the floors from this model. And then I should be able to pull stuff out. So there's no, floor, that's why. There's no native Rhino support, but for Grasshopper, I can just plug that in and it'll deconstruct all of the properties of those floors, and here they are in Rhino. So with a little bit of Grasshopper help, I can get Hypar geometry into Rhino.
Okay, great, thank you.
Can I ask one more thing?
Yeah.
Is there any possible? I mean, I think it's a question about dependencies. Is it possible in Hypar? Is it possible to relate the models which has been created with different tools, like one from Grasshopper, one from Dynamo, and being related to each other as a dependency? Would that be possible?
So when you publish a Hypar function with Grasshopper, in fact, let's just pull up an example. Do I have an example? Actually, yeah, let's try this. So I'm going to do a solar analysis. This is an old function, so there's a chance it won't work, but let's just try it. So this function is written in Grasshopper, in fact, and it has model dependencies on envelope and location, just like any other function in Hypar. So it's possible to build functions with Grasshopper that participate, there we go, in the full sort of stack of a Hypar workflow. So you can, and this works upstream too. I could take my Grasshopper function up here and depend on it downstream. The other thing you can do is you can import Rhino models. So in fact, let me just see if I can pull up this other example. Where is it? So this is an example where actually most of the functions in this workflow, once they load, are Grasshopper functions. Actually, C#, Grasshopper, Grasshopper, C#, Grasshopper, C#, Grasshopper. So they're kind of all plugged in together. And I'm also taking advantage of the ability to like drop in a Rhino model, which is the kind of facade panel that I want to use. And hopefully this will work. I haven't tested this one in a while, but let's try I'll drop in a new Rhino model here. And this is like a different facade panel that I want to create. And the Grasshopper definition down here, this function is responsible for distributing that panel across all of the facade. So, oh yeah, it didn't like that. Let's try it without adaptive scale. So yeah, basically you can plug in those, yeah, this one is not happy. But in general, the answer to the question is yes, you can take any existing Grasshopper model and make it a function. And you can also take static geometry. Like you can, when you're working in the Grasshopper context, you can also produce a JSON file, which is like an elements file, and then import that in using a function called JSON to model, which will allow you to like drag and drop a new piece of geometry in here and plug it into the later workflow.
I see. And you're planning to create like a function, the tools for the Dynamo as well to create function?
Currently, that's not on our roadmap. You know that Ian Keogh, who wrote Dynamo, is the founder of Hypar. So we know the Dynamo team really well, and we understand Dynamo really well. So far, there hasn't been a lot of demand for functions written as Dynamo scripts. There's really no technical reason why we couldn't. It's just not something we're currently prioritizing. I would say probably next on the roadmap is Python. We want to enable Python functions, but that's also largely going to be a function of what our customers are asking for. So if somebody really wants to be able to take their Dynamo scripts and put them on Hypar as a function, then we'll find a way to support that.
I see. When you say C# or Python, are you relying on like Rhino common or is independent?
So the beauty of Elements, I'll just put it here. Elements is in and of itself a geometry library. So when you write a C# function for Hypar, you can use the Elements library to do all of the geometric calculations you want to be able to do. Vector math and all that stuff.
Sounds great.
And that's true in Python too. When we support that, it'll just use a Python version of Elements.
All right. Well, that sounds great. Thank you. Thank you.
Yeah. Should we move into some function authoring demos?
Yes, please.
Okay.
Thank you.
And throughout, please feel free to ask questions either in the chat or just speak up. I'm happy to pause as I'm going and answer any questions as they come up. So in order to make actually, let's use this other account. In order to make a Hypar function in Grasshopper, you will need this Hypar plugin for Grasshopper, which you can get by going to the Rhino package manager and searching for Hypar. On Rhino 6, you have to type test package manager to get this to show up. On Rhino 7 or later, you can just type package manager, and on Rhino for Mac, it's just package manager. You can search for Hypar elements for Grasshopper and hit install, and then when you launch Grasshopper, it should be here. And the way that this works, I have to set up my function so that Hypar knows what I want to do with it. So let's take a simple example where I'm going to have, a slider for, I'll just make a box, and I'll repeat this example in C# so you can see how they're different. I'll make a box with width, length, and height. Oops. And normally what I would do is I would just construct like a domain box or something, or a center box. I'll just use domain box for now. And so this is my amazing Grasshopper script that I want to put up on Hypar. So I have to do a few things so that Hypar knows what to do with this. And I might also have to make a little change to this script. So the first thing I will want to do, let me just resize this window, is I have to describe this function and indicate that it is in fact a Hypar function. So there's a Hypar function setup component, and I'll say my first Grasshopper function. And I'll say makes a box. I'll make a little description. And I also need to designate the inputs, these sliders, and say that these want to be Hypar inputs. So for that, I'm going to use a function input. And I can just plug my sliders directly in. I'll make 3 copies of this. You don't want to plug a bunch of inputs into the same component, and you also don't want the same input controlled by multiple function inputs, because it expects them all to have unique names. So we'll just create our Hypar inputs. And then we also want to produce some geometry for the model. And we can do this a few different ways, but we'll have to specify a model output, and I'll say, I'm going to call this box. That's going to be the name of the model that I'm contributing to Hypar. And actually here, I'm up here in this funny corner. So when you pass something out to elements, like it doesn't know how to turn certain geometry types into Hypar elements automatically. I think if we turned this into a mesh, that this would actually work, because it knows how to create a mesh element for Hypar. But typically you don't want to do this. Typically you actually want to construct an element of a particular type. Again, elements being sort of Hypar's logic for describing building systems. So you want to create a sort of meaningful object, not just some raw geometry. So for that, we're going to use construct element. And this component may not look super useful off the bat, but if you right click it, you have access to all of these different element types that you could create. So we're going to create a mass, and it takes on the inputs that it needs. So it wants a profile and a height and maybe a material, but let's just start with the profile and the height. So in this case, to build a mass, I'm actually going to build the profile and the XY first, just as a rectangle. And then I'm going to use this other value as the height. Oh, and incidentally, you can use the values that are coming out of these inputs. You can also just wire up the sliders directly. Things don't have to come out of the input components. They work kind of backwards. So I've got my inputs. I've got a profile and a height. And I'm just going to delete this box. And you'll see that it's created, we're getting a little clipping here, but it's created a box, which is going to be my mass. And I'm going to plug that in. And so now this is ready for Hypar. I've designated my function name and description. So this is how it'll show up in the function library. I've specified some inputs. I've created some elements, and then I've passed those elements out to model output. So let me just save this as example Hypar function. And let me go back to Hypar. So I've got all of my workflows, which are these groupings of functions. And I've also got a list of functions that I've authored. And you can see some of them have a Grasshopper icon. Some of them have a C# icon. I'm going to say, I want to make a new Grasshopper function. And I'm going to drag that file that I just saved. And it's going to upload this to Hypar's cloud and parse out all of the information that we specified in those Hypar components. So it'll read the name and the description and the inputs and so on. And so it knows that I've got my name, my description, my inputs, my model output, and I can go ahead and publish this function. Importantly, when you make a function on Hypar, it is by default private to you, so no one else can see it or use it until you decide that you want to share it with the world. So this is good when you're still debugging or trying stuff out. You can keep it private, and then when you're ready to share it, you can share it. You can also create functions that are just belong to your firm by doing domain access. So I can say, you know, only nbbj.com email addresses get access to this function or whatever. So I'll hit close. And then I should be able to create a new workflow. And what did I call it? I called it my first Grasshopper function. There it is. I'll hit add. And now it's created that box. I can do things like sample range on it, and it'll actually execute all of these in the cloud. One of them didn't work because the value was 0, of course. But I can now quickly use this. And that's actually another benefit of putting these on Hypar, is that you get this sample range functionality right out of the box. You can sort of test different combinations of parameters and do sort of a study. And if there were if I had produced an output that I wanted to optimize for, like volume, I could sort by that and choose the values that had the highest outcomes or the best outcomes. So it's sort of like a little bit of generative design. So there are lots of other things involved in the Grasshopper function authoring world. You can construct more complex geometric representations. You can create instances. You can create materials. You can work with our Elements Grid APIs, which are a really flexible way to do 1D and 2D grids based on curves. But I think for now, I'm probably going to leave it at this so that we'll have time for the C# examples, which we'll go into a little more depth. But then I'll also make sure we leave time for questions after that as well. But just for now, are there any questions about what I just showed with the Grasshopper functions? We can, oh, go ahead.
どなたか質問ありますか？皆さんついていけましたか？ Okay, we can go ahead. Thank you.
Yeah, sounds good. And yeah, feel free to throw in other questions as we go. The other thing I'll say is that we're in the midst of a big rewrite of this functionality. Pretty soon it will be even easier to create functions in Hypar. It will require fewer components in your Grasshopper script, and will allow things like live debugging. But I'll talk about that a little bit later. So the way you author a function in C# is a little bit different. So I think I mentioned in the invite. So if anyone wants to follow along, there's some instructions in the invite. I'm going to go pretty quickly, but this is something maybe you can review a recording later on and play around. But effectively, developing a function in C# for Hypar, we have developed a sort of command line utility. So you'll use your terminal, and there's a Hypar command that has all these functions that are useful for getting new projects spun up. So in order to do all of the things that I'm about to show, you need to make sure that you have the .NET 3.1, .NET Core SDK. So that's this guy, which is what allows us to build these command line tools. And also we recommend using Visual Studio Code as your development environment. You can also use Visual Studio, but I like VS Code. I'll talk about why in a little bit. But the first step, so once you have all those things installed, you need the .NET SDK and you need the Hypar command line, which you can install. Once you've got .NET, you can do .NET install or .NET tool install -G for global Hypar CLI. And that will get you set up with that Hypar command line that I just showed. And then we're actually going to sort of design our function in the Hypar web interface before we start building out the code that supports it. So also in this your functions row, I can click new function. When I go to new C# function, I have some slightly different options. So I'm going to call this my first C# function. And if I want to make this open source, I can also provide a link to a GitHub repository. Also, everything that we set in these inputs now, we can always come back and change later. So don't worry if you don't know an answer to one of the things or if you want to change a decision you've made. This is one of the more powerful pieces of this UI. It's what allows you to compose the interface for your function. So if I want to just create a box, I can drag in a range of a set of sliders, and I can say, okay, I'm going to make length and width and height. but I can also plug in other kinds of inputs, like I can put in a color or a polygon input. We'll look at these all a little bit later. Once I've specified my inputs, I can also click this preview button to see what they will look like in the Hypar interface. And I can do things like control the range, like maybe I want the maximum length to be 200. And the value that I set here becomes the default value for this function. So if I want the default for this one to be 100, I can set it as such, or I can click here and type. And then this becomes the default whenever anybody adds this function to a Hypar workflow. Next up, these controls are all about specifying the relationship between functions, a model output or a model dependency. I'm not going to use this now. If we have time, we can maybe get to an example where we make a function that depends on another function. And then element types are where you can specify additional custom element types that you want to develop. So I'm going to take a little bit of a detour here just to explain this. So there are some built-in element types that we can use, like envelope and floor and things like that. But as I mentioned before, elements is extensible. You can define your own types without having to submit any PRs or change anybody else's code. And the way that this works is that we use a technology called Json Schema. And Json Schema is how we describe the class or the type for every element. So if I wanted to invent an element type called lift shaft, I could just write up a JSON file that describes all of the properties that a lift shaft wants to have. And all I have to do is put this JSON file on the web. So if I wanted to create a lift shaft in my function, I can just get the URL to this JSON file. And we use GitHub typically, but you can actually host these anywhere. I can just add this, and it will create a lift shaft class when I go to create my function. I'll talk about this a little bit later. That's more of an advanced topic, but I just wanted to mention what this is for. Finally, I can add output. So let's set a numerical output called volume. And let's make it the volume of the box. And we can also set units, so it'll show up as like cubic meters or whatever. And click next. And then we'll publish our function. And once you publish, you get this command, which you can copy to the clipboard and run in your Hypar CLI. Now, you also, the first time you do this, you also probably have to do Hypar sign in to just log in with your Hypar account. So I think I'm signed in currently. Yeah, I'm signed in as the right user, but if you haven't done this, it'll prompt you for it when you paste. So you'll want to use your terminal to change directory into wherever you want your functions to go. I have like a repositories folder, which I'm currently in, but you'll want to make sure to CD into whatever folder you want your function to be created in. And then you can paste that command that we copied from right here. And what this command does is it says, okay, tell the Hypar command line to create a new function based on this ID. And this ID is the ID that's been associated with this function that I just set up in the inputs. So let's just go ahead and let this run. This process takes a little while. It has to go fetch the definition of your function, which I called my first C# function. And then it's going to go create a bunch of files for us in this folder. So it's basically spinning up a complete Visual Studio project for your Hypar function. So it's creating a series of projects, it's generating some classes, it's doing a lot of really smart stuff on your behalf so that all you have to do is write code in one place in order to author your Hypar function, and all the other stuff around it gets handled automatically for you. So we'll let this keep running. It creates a default unit test for you. So if you're interested in writing a function that has unit tests, you can add those to a test project. It's really configured to reflect kind of modern software development practices. It creates a Visual Studio solution, so you can open this in Visual Studio. Typically, I don't use Visual Studio. I use VS Code because it's lighter weight and because it allows me to see some of these other files, like the JSON files that get created at the same time as source files. And Visual Studio doesn't do this off the bat, although you can make it. Oh, we got an error. That's unusual. Let me just try it one more time and see. Usually this one is just a fluke. The structure of the function that it creates for you, let's just take a look at that real quick. So it creates a folder for you, and that folder has some JSON files, a source directory, but there's really only one file that you need to worry about, which is the function. It has basically the same name as the function you created, and it has an execute method in it. And when you start, there isn't much in this execute method, but I'll talk a little bit about the structure of this method. It has this is the method that basically gets executed every time your function is run on the cloud. And it has an input object, which contains automatically all of the inputs you defined in the web interface. So when I made width, height, length, those are now properties on that input object. So let's see if it finished creating. It looks like it's working this time. So it'll go ahead and upload this function for you, even though it won't do anything. But it's very easy to publish new versions of this code as you like. So we'll just wait for this to finish. The other thing I'll point out is that you wind up needing, as you're building these functions, to refer to the elements documentation, which is available. You can get to it from the Hypar web interface by going to the Hypar menu and choosing developer docs. That'll open in a new tab all of the docs. And if you click elements, you'll see the complete documentation of our API. So these are all of the methods and tools that you have access to when you're writing a Hypar function. And for C# functions, you can also pull in other packages. You can pull in NuGet packages and so on and so forth. And so you can build pretty sophisticated functions. So, okay, I believe it has finished. I'm going to open this function in VS Code. And this hypar.json file is basically a configuration that captures all of the choices you made in that web interface. You can also edit it here, and often advanced developers will do that, but I recommend when you're getting started to only edit this in the web interface. So here's our function. Here is our execute method. This input object, if I go look at this class, has been generated for me, and it actually has all of the properties that I defined in the web interface as properties on that class. So one of the things that happens when it's running through all of that stuff is it's generating a bunch of source code for you. So it's taking the choices you made, like length, width, and height, and turning those into an inputs class. And similarly, my outputs class has this volume property on it. And that is what I'm responsible for returning from my execute method. So you basically just define a method, you have access to all of your inputs, and then you have to produce an outputs object. So let's go ahead and build a box. We're going to do our same silly hello world, but we'll make this one a little more advanced as we go along. So I want to create a box, and it's actually going to look a lot like the way I did this in the Grasshopper context, where I first created a rectangle, which was my profile, and then I set a height on it, and the element that I created was a mass. So let's see how that happens in C#. So I want to create a rectangle. So I'm going to say var rectangle equals polygon dot rectangle. And I need to specify a width and a height for this. And I'm going to use the values in my inputs object. So input.width, input.length, And now I've got a rectangle. And now I want to make a mass out of this. So I'm going to say var mass equals new mass. And I'm going to pass in this rectangle as the profile. I'm going to set the height to be input.height. And I can just leave it at this. I could also specify a material and other things if I want, but we'll leave it at this for now. And the last thing I need to do is actually attach this mass element to this output. The other thing we want to do is produce the volume value. So this outputs class has an empty constructor, but it also has a constructor that takes in whatever output values I specified. So this is where I can tell it what I want the volume output to be. So in this case, I'm just going to do some math on it. Rather than measuring the volume, I'll do input.width times input.length times input.height. And to put the mass in this output object, we use output.model.addElement mass. This mass class is itself a geometric element, which is in turn an element. And so anything that we're going to put in the model has to be an element in order for it to show up or in order for Hypar to know what to do with it. So this is pretty much ready to go. I'm going to save this file. I'm going to open up the integrated terminal in VS Code. That's the other thing I really like about VS Code is having my terminal in one place. And I'm going to use that same Hypar command line to do Hypar publish. And what this is going to do is build my source, compile it into a DLL, create a little package, and then upload that package as a Hypar function. So it's finished uploading and it's finished updating the function record. And now when I go back to Hypar, if I've just created a new function, oftentimes I'll have to reload in order to get it to show up. But I'll create a new workflow and I'll go find my first C# function. There it is. I can click add. It has the defaults that I set earlier, and it's created this mass. So far so good. We've got a cube. Let's make some changes to this. Let's add a color input, and let's give this a material so it's a little prettier than this like little transparent cube. So I'm going to click the About link. And I'm going to go to my inputs. And because I'm the owner of this function, I can go in and edit any of the choices I made earlier. Other users obviously won't be able to edit this function. And now I'm going to drop in a color input. And I'll say box color. And I'll set it to a nice, let's do like a kind of a gray green as my default. And I'll hit Save Changes. And I'll close. And of course, our function doesn't know what to do with that yet. Our function logic doesn't know about that color input. So the other command we need to use, and in fact, this you can find, where'd we go? Whoops, where was that? Oh, I must have gone back, that's why. So if you go to logic, you can see a reference to all of the commands that you might need to use. So this is the one we used initially to set up the project. This is the one we're going to use to pull in any changes that we've made to this. So I'm going to use Hypar pull and Hypar init. And those two commands together are going to pull in the changes I made. And Hypar init is going to regenerate the inputs class. So now you can see the inputs class has this box color property, and now I can use it in my function. So you'll notice that there were a few optional arguments to mass that I didn't use, like material. So now I'm going to create a material, but first I'll just say, I'm gonna give it an arbitrary material or a variable name called material. And I'll say var material equals new material. And then it wants a color and a name. And I'm going to use the overload that starts with the name and then the color. So I'll say box color is the name of this material. And I'll use box color as the property. And so the class that got generated is of the correct type. So there's a lot of this sort of like, type alignment between the inputs that you set up, the types you can use in Hypar elements, and the types you can use when you're authoring a function. And so this should be sufficient. I've just attached this material to this mass, and I should be able to publish again. Now, you can imagine that this process of kind of waiting for everything to publish can be a little bit tedious when you're trying to quickly iterate. So there's another way to build functions or to work on your functions while you're still developing them, which is what I'll show you next. But first, let's just verify that this actually worked. Okay, it has finished. And we can go back here. And I might have to change one of the inputs to get this to execute. But if we did our job right, it should be green, and it is. And I can maybe pick another color. And there we go. So as I mentioned, it can be a little tedious while you're developing if you're debugging or trying to figure something out to constantly do all of these edits, pull, publish. It's just sort of a slow cycle. So we have another way of working with this. And to show that to you, I don't know why this window is so big. I'm actually going to delete the function from the workflow temporarily. And I'm going to go to the Hypar menu and choose test a local function. And this is going to give me yet another command I can pull into the Hypar CLI. And I'm going to go back to my function. And I have to make sure I'm in my function directory when I run this command. But what this is going to do is, if you've done any web development, oftentimes Webpack will let you do like a hot reload, where as you're editing the code, it just rebuilds and reserves the resulting web page. And this works in a similar fashion, where it's basically constantly monitoring your code for changes, rebuilding them, and then serving them up to the Hypar web interface. So when I'm ready, when I see this green ID, I can click ready, and it adds that workflow, or it adds that function to my workflow. But it's this dotted line indicates that it's running locally. It's not actually on the server yet. It's actually executing my code locally, which means that if I did something like make the width twice as long, and if I hit save, it should become twice as wide right on the fly. So this is much more like an experience you might be used to in Grasshopper development, where you're just quickly iterating and testing things and re-executing them. So this is the way that I like to build functions. So let's actually remove that, and let's make one other change here. Let's put a hole in the middle of our box. So right now, I'm providing a profile to this mass. And a profile in Hypar Elements can support either a single boundary or a boundary with holes in it. So if I want to create a mass with a void in the middle, I can create a new profile that has an outer boundary and voids within it. So let's create a new profile. And I'm going to pass it my existing rectangle as the perimeter. And then I'm going to pass it a new polygon as a void. So I'm just going to call this my inner rectangle. And I haven't created this yet. So I'm going to copy this line and paste it and make my inner rectangle. And for this, I think what I'm going to do is just make this times 0.5, make it half as big as the box. And the last thing I need to do is actually tell the mass to use this profile instead of the rectangle that we used initially. And so now it's got a hole. It should interact as I make changes over here. You can see that when it's running locally, it's quite snappy. The other nice thing is that a lot of the existing functions, like let's take envelope by sketch, for example, they have links to the code that these functions were written with. So if I want to go see how an existing function works, I can just go straight to its source. Now, not every function exposes this, but a lot of the ones that the Hypar team have written do. And that's really nice. It means that you can just sort of see what sort of patterns and techniques people are using to author their functions, how they're configuring their inputs, how they're constructing stuff. For more sophisticated functions, it's really useful to be able to look at this. The other thing I'll point out about our docs, which I went to earlier, is that the elements documentation has 3D visualizations of a lot of the classes. So you can actually see a little 3D preview of the mass in the docs, which I think is really nice to be able to get a sense of like, you know, okay, I want to work with the Grid 2D API, let's say. Actually, that's in spatial. So let's go find that. So I can see like an example of how to work with the API, and I can see the geometry that's produced by that example. So we're trying to make it really friendly to developers to kind of get up to speed on how Elements works and have lots of resources to learn from. But we're improving this documentation all the time. And we publish a lot of tutorials and stuff to our YouTube channel as well. I can keep doing examples, but I think now would be a good time to pause and take some more questions. And then maybe I can actually steer some of the additional examples based on the questions that come up.
Thank you for the presentation. It's great, and I really like to try this. Sounds really a lot of fun to code and good documentations and a lot of potential for designers like us, the competition of designers. Then let's ask some questions for members. 誰か何かクエスチョンありますか？質問ありますか？どうですか？ここまでで。堀川さんどうですか？
I have a question on it. Is it possible to use like a external REST API to call to get some data from other web pages?
Yep, absolutely. In fact, our own location function does this. So the location function uses the Mapbox API and it's making a call. Because all of this is just regular .NET Core C# stuff, you can use whatever library you want. You can use system.http web client, or you can use REST Sharp, whatever you're familiar with. And you can totally just call into other examples. I may or may not have published it, but I have an example. Hold on one second. I believe I've just been doing a training session over this past week, so I have a few pretty recent examples that I pulled together for this stuff. 1 second. Training. Function examples. Table test. Okay, so one example of this is I wrote a function that uses Airtable, and it was pretty easy actually. Where did it go? Oh, I'm hiding the window. Here we go. So if we go here, I'm probably like exposing all of my like secrets and stuff, but whatever, I'll change them. So yeah, basically, I mean, it couldn't be any simpler. I'm just creating a REST client, calling a REST API, doing stuff with it, and making geometry as a result of it. So there's really a ton of flexibility when it comes to working with third-party APIs. The only limitation is that Hypar functions have to execute in under, I think, 15 seconds. So if it's a really slow API, you might have to get creative about how you take advantage of it. But yeah, that's very much a possibility.
I see. That sounds really great. You have mentioned about the security issues using like C# component on Grasshopper, but is that okay using like external DLL for those job functions?
So the reason it's an issue in Grasshopper is that we're using our kind of own flavor of Rhino compute, but that means there's a running instance of Rhino somewhere and it's kind of all happening in the same execution environment. Whereas for C#, we can use much more modern techniques of kind of truly isolated microservices. So in fact, you can use any external DLLs, you can use any NuGet packages, you can do whatever you want, and it's totally isolated from any other function. So there's no security risk doing that.
That's really awesome. Yeah, thank you. Thank you for the.
Yeah.
他にいらっしゃいます？こんなことできますか？クエスチョンなど。
Well, while we wait for other questions, the one other thing I'll say is that speaking of external APIs, you can also use Rhino Common, Rhino Compute if you want. So I have written Hypar functions that just call on the Rhino Compute APIs to do various things. So I think I have an example of this somewhere. There's, oh, I know where it is. Functions. So actually, this is an example due to Will Pearson from the McNeil team. He was playing around with Hypar and he wrote a function called Rhino Head that uses the Rhino file IO to read in Rhino models in a C# Hypar function. And then you can also use so actually this one doesn't have compute, but then somewhere I'll dig up the example. Let's see. Yeah, there are a few other examples of you can pull in the regular C# Rhino compute stuff and use that within your C# functions for Hypar if you would like.
Sounds awesome.
If there are no other questions, I can show one other thing which I think is useful to understand, which is the kind of dependency thing and understanding how you write a function that might rely on another function. So let's see, I hadn't prepared this example, but we'll kind of improvise. And I think we should be able to get it to work. So what I want to do is make a function that add cubes to envelope. This is still kind of a silly contrived example. So what I want is I'll make a slider, which is like the cube size. And I want it to produce cubes, but I want it to have a model dependency. This is how I tell my function that it relies on the output from some other function. So I'm going to say, give me the envelope. And how do I know what to put here? It's useful to answer this question. So if I am in Hypar, like here, and I have a function like envelope by center lines. I can click about. Actually, let's use envelope by sketch for this. So I can see the model output name, which this function produces. I can also see the element types that it uses. So envelope is actually not built into Hypar. It's another element type based on a schema. So in fact, this link will show me the schema for an element. So I'm going to need both of those pieces of information here in a second. So I specify that I need a dependency on envelope, and I also need a reference to envelope. Now, envelope is available in this list automatically, but I could also have just taken this link and pasted it here as well. If I go to custom URL, I can just paste that, and it will bring in a reference to that custom element type. I'm going to use the built-in one for now. And let's just leave it at that. I'll hit publish function. I'll pull this in, and I'll go back to my terminal, and I'll do Hypar new. And so this is going to spin up yet another project. What we've seen before is that when I choose my inputs, like height, width, length, whatever, the inputs class gets automatically generated for me, and it has all those properties. The same thing happens with any elements types that you refer to. So when I specified that this function was going to use the element type, it's actually going to use that element schema, which we just looked at, and it's going to generate a class for me. So this is a key part of how this ecosystem works, is that by defining all of our types through this kind of consistent schema, you can just have a class representing that type in whatever environment you're working in, whether it's C# or Python, or that's the same way we automatically generate the inputs for those components in Grasshopper and so on. So being able to kind of concretely describe all of the properties of a given object allows us to make classes wherever we need them. So this is going to create that envelope class for me, and it's going to create a function that says, I require envelope. And so I'm going to be able to plug it into a workflow and have access to any of the envelopes that are present in that workflow. So once this is done, we'll open it right up. The other thing to note as we're talking about elements is that, here, I'll just draw a polygon. Is that you can inspect not just the geometry, but also the data associated with all of your elements by going to the outputs panel. You can see this table, which shows you all of the elements that are present. You can pop this open. So there are 3 envelopes that were created by this method, and they have these properties: elevation, height, direction, rotation, and so on. And they can also refer to each other. So this envelope refers to this profile, which is one of these profiles, which has some polygon shape. So you can kind of get a look at the raw data that constitutes these elements directly within the UI. You can also publish this if you need to make a little table that visualizes those elements. That's how you start to create a kind of custom dashboard. So, okay, this is done generating. I'm going to open it in VS Code, and we can see that it's got a reference to that element type, and my dependencies project has automatically generated an envelope class, which is a geometric element, which has all of those properties like profile, elevation, height, direction, and so on. So now I can just work with it in my own code. It's kind of nice that it produces it as source code rather than as like a DLL, so you can really see what's going on in all of these classes. So, okay. Get rid of this. What I want to do is get all of the envelopes that I depend on, get the envelopes from the rest of the model. So when you specify a dependency on another function, it populates this input models dictionary with any of the dependencies you've asked for. So I can say var envelope model equals input models envelope. And now this is going to be an object of type model. And then if I want to get all of the envelope objects or elements out of that model, I can say var envelopes equals envelope model dot all elements of type envelope. And then this is just going to give me all of the envelope entities that are present in that model. Now, we also saw that there are other things that are in that model, like a material and a profile. So I could also get the material out of this model or whatever if I wanted to. So now what I want to do is calculate a point at the center of every face of every envelope and put a box there, at least on the sides. So the way I'm going to do this, I am going to go down here and I'm going to say for each var envelope in envelopes, I want to get the profile of the base of that envelope so I can find the midpoints of the segments that constitute it. Because one of the things that's different about elements versus like Rhino Common is that typically we're not working so much with solids and B-reps. We produce them, obviously, but you're going to have better results if you work with the kind of generating geometry, like the 2D generating stuff that produced it, rather than I wouldn't go get the faces of this. Instead, I'm just going to get the profile and calculate where those locations can be. So var profile equals envelope dot profile. And I actually just want the outer ring of that profile. I could get the inner one too, but let's just, if there were one, but I'm just going to get the perimeter. So var perimeter equals profile dot perimeter. And I want to create a box at the center of every one of the segments of that perimeter. So we're going to have to do another loop to loop over the edges of that perimeter. So for each var segment in perimeter dot segments, there's a method that'll return a list of lines that constitute that perimeter. I'm going to get the midpoint of each segment. So var midpoint equals segment dot. And similar to, I think, a lot of APIs we've seen, these are parameterized curves. So if I want to get the point at the middle, I can just do point at 0.5. You know, same as you would in Dynamo or Grasshopper. And now I'm going to create my mass. So just like we did before, I'm going to make a rectangle. Polygon.rectangle. And I'm just going to use the cube size for this. And I'm going to make a mass that uses that rectangle, uses the input.cube size as the height. And I'm going to use a built-in material here. There's a built-in materials class that has some materials that you can use out of the box. I'm going to use the x-axis material, which is red. And then rather than, so you'll notice that I constructed this rectangle at the origin. I didn't actually construct it where I want it. And this is a common pattern in elements too. Typically, we construct stuff kind of at the origin and then use a transform to put it where we want it. Most elements work that way. It's kind of up to you. It'll work both ways, but I find this to be a cleaner way to work. So in this case, I'm going to create a new transform located at this midpoint. And you could, there's one of the arguments to, or one of the overloads for the transform constructor lets you specify a point or a vector 3. So I'm going to do the midpoint. And let's use that live debugging method in order to check that this is working and quickly make some changes. So I'm going to test a local function, grab this command, paste it in here. It's going to build that for me. Oh, I've forgotten something, but we'll start with this and then we'll edit once we get it going. Oh, let's see. Oh, I already have one of my VS Codes running the Hypar run, so you can only have one of these going at a time. Let's try that again. So this is just about ready. And I can click ready, and it'll put in my new function. And nothing is coming out yet because I have forgotten to add the mass to the output model. So I'll just do that real quick. Output.model.add element mass. Save that. If I go over here, I should see my boxes show up. They're very big, but there they are. And they are all located at the kind of XY plane. And they're all located at the midpoint of those edges. So that's mostly what I wanted. Now you'll notice that they're all oriented along the XY, and I might like them to have an orientation that's parallel to the facade. So instead of using point at, I think what I'm going to do is use segment.transform at 0.5. So I can actually just get a transform from that location. And then in that case, I don't need to create a new transform here. I can just say pass midpoint, which is now a transform. And now this should cause those boxes to rotate so that they're parallel to the facade. The next thing I want to do is move them to the midpoint of the face. So if I'm thinking about this, I want their height to be half the height of the envelope. So what I'm going to do is actually modify this transform that I've just created. And for clarity's sake, I should rename this because it's not really a point. It's a midpoint transform. What I want to do is concatenate another transform onto this one. So I'm going to say var, actually, I'm just going to say midpoint transform.concatenate new transform. And I can just specify an origin here, which will be the envelope height over 2. And that should move it up to the middle of each face. Except there's one more thing that's missing, which is that these envelopes themselves have a transform, which is they're actually all constructed at the XY plane too. And they have been given a transform that moves them up into space. So the last thing I need to do is also append or concatenate the envelope's own transform. So I'll just say midpoint transform.concatenate envelope.transform. And there they are. So now we've created our little boxes that sit on the facade. Theoretically, if I edit this, it should pass that down. So that's the other advantage of this kind of live edit workflow. Sometimes it takes a minute to recompute, is that I have the advantage of working with all of the other data in the workflow, and I can kind of debug against it, which is really helpful. And yeah, this pretty much works. It's pretty much ready to go. Are there any questions about that?
どなたか質問ございますか？
質問でもいいですか？
OK です。
So, thank you for your presentation. I'm a structural engineer, and now I found the function in the Hypar structure with backlink. Is it possible to calculate some structure analysis? Is it possible?
So it depends on what functions are available. It looks like one of our users is probably a structural engineer and has authored a function that does this. We don't have any utilities out of the box that do any sort of structural analysis. So it's up to you to add those kinds of utilities. Maybe there are libraries you can rely on and you could plug those into a Hypar function. And we expect that over time, we're working already with a lot of, not just architects, but also engineers and contractors and all sorts of folks in the building trades who are starting to contribute functions. So I would say over time, our hope is that, yes, you'll absolutely be able to do like a structural analysis of something. I don't know anything about this function. I don't know what any of these numbers mean.
Yeah.
But in theory, you should be able to use this function or use some function to actually do structural analysis on your own design projects.
はあ、なるほど。あ、thank you so much.
Is there any already implemented like external plugin for structural analysis?
Not that I know of. I know there's a company called SkySieve that does a lot of like cloud-based structural analysis, and some of their engineers have been playing around with Hypar and offering some Hypar functions. So I think that stuff is all going to come eventually, but I don't know if there's anything publicly available yet.
See, something like Caramba plugin for Grasshopper. Would that be on the road? Or not?
Yeah. So, I mean, Caramba itself, we don't support in the Grasshopper functions. What I don't know, do you know if Caramba is open source? I don't think it is.
I don't think. I think
I
it's.
don't think it, yeah.
Yeah,
Caramba
I think it's not.
オープンソースじゃないですよね、鈴木さん。カランバって。
いや、no, そう、違いますね。さすがに違う。
Yeah.
違う。So it's not an open
It's
source.
not the
And so, there are a couple options. One is we could add support for Caramba to the Grasshopper plugin ecosystem. We could say you can use Caramba in a Grasshopper function on Hypar. I think we would prefer to actually support the library directly if there's a way to do that that isn't reliant on Rhino Common. But yeah, I mean, we would love to go there to have something similar to Caramba on Hypar. So it's just a matter of either us reaching out to that team or that team reaching out to us to figure out how we can make that happen.
I see. I see.
When it comes to calculation or simulation, the reliability is a matter, I think. So how do you have any function to rate the function, evaluate the function? For example, some function could be popular, could be not reliable, or how to see the function's popularity or reliability.
That's a great question. Currently, we don't really do any user-facing ranking of functions. The only thing we do is that we order the functions in this list based on how likely we think you are to use it based on the functions you already have in your workflow. However, I think we're going to be doing a lot more work as the ecosystem grows to kind of filter out and celebrate functions that work really well and that are really useful, so that the ones that are maybe somebody's just test or whatever don't show up as high. We haven't done a whole lot with that yet, but it's definitely something we've talked about quite a lot. So
that's great, because I think this Hypar will change the job of us, like the computational designer's job. We could join that, and if the Hypar became like a YouTube, and we just join and upload some code and evaluate, and if some code used a lot, then maybe in the future we can earn money from Hypar or something.
Yeah.
That's like
absolutely part of the plan. Yeah, no, we intend absolutely to compensate function authors down the road. We haven't yet even started charging people for the platform, so we can't very well do that yet. But I think eventually we will enable you to author functions and put, maybe it costs 10 cents every time you run an execution on it to the user or whatever. And so you can, I don't know how we'll structure that exactly, but that's always been part of the plan. I don't know if anyone can ever be, like a full-time Hypar function author, although that would be amazing.
That would be amazing. I mean,
I would, I hope. Yeah.
I really hope
but
so
at least as like a supplementary income. And at least, one of the things I love about our community is how giving people are. and they just want to put their amazing work out there for free. And you know, I've contributed to this, but I've also really benefited from it, all of the amazing work that people have put out there. And so we want to support that first and foremost, but we also want to make it so that it's easy for those people to actually get some direct benefit from putting in the effort to, you know, to author functions in this ecosystem.
This would be amazing because I saw the copyright of the code that is really not happening in like my working environment. So always like we made a code, but we just like dispose the code at the same time, and we really do similar job repeatedly in different projects. So if we could, like that Hypar became the platform, then our job would be more beneficial and meaningful. So I really like the concept and how you see the future of this service. So thank you very much for showing this amazing session. I really liked the session, and also we really have a lot of hope for this paradigm shift comes in Japan as well.
Awesome. Yeah, well, I mean, thank you all for attending, and please, if you are interested in starting to write Hypar functions, like by all means, play around with it, and anything that I can do or our team can do to help you, please don't hesitate to ask. We would love to have have Hypar really start to take off in Japan with all of the amazing folks who are on this call. Anything we can do to support you, we'd love to. And the one other thing I'll say is that we have a Discord group. So if you go in the Hypar menu, there is a link to our Discord, which is like a sort of a chat channel similar to Slack. And that's a great place to ask questions or interact with other Hypar users. There's also some really cool discussions about like the future of the industry and everything that's going on. People are talking a lot about, you know, the future of the profession, about machine learning, about AI and all kinds of stuff. So this is a great community that we would love for you to be a part of as much as you're interested. And it's a great place if you're running into trouble. You know, if we help people debug doing stuff like this. So
that's great. Do you have any example for using this as educational training? Because I think this platform also great to teach algorithm or teach logic in university or something that I felt.
Yeah, there are a couple academic programs that have started to use Hypar. I think David Gerber's group in SoCal in USC, I think, has been starting to use Hypar a little bit. But not a whole lot, partly because in order to write a function, you need to know either Grasshopper or C#. Right, and that's already, I think, a difficult thing in schools, although there are a lot of schools that are doing that. But, you know, we would love for this to be a resource for student projects as well. And, you know, I mean, I think part of the reason why Grasshopper has been so successful is because 8-10 years ago, it was really popular it's still really popular, but it started to get, like, I think students were really the first group that really attached to Grasshopper. So if we can have a sort of a similar relationship with schools with Hypar, that would be amazing. So.
Thank you. 他にどなたかいらっしゃいますか？何かコメント、そろそろ時間がもう少しできちゃうので、クジンさんとかどうですか？
Thank you for talking about Hypar. I'm glad to meet you because the human UI you developed has helped me a lot.
Okay.
I'm not very good at English as I'm learning it, so I'm sorry if some expressions are hard to understand. To ask them to find the words.
It's okay.
When I first saw Hypar, I thought this was a service to share the code .gh file, but I realized that it was actually a service that allows us to develop more freely and also frees us from spontaneous code. So I'm very much looking forward to the future development. Thank you very much for your time today. Thank you.
Yeah, thank you. Yeah.
他にはどなたかコメント、ここでありがとう言いたいっていう方いらっしゃいますか？どうですか？レンさんどうですか？ルカさん最後にコメントどうですか？
Yeah, that was a great session. I really learned a lot from the stuff. That all sounds really magical. Still sounds really gotta try this out myself to see the possibilities, and would like to make some functions myself as well.
Awesome. Yeah, and I mean, the other thing I'll say is that it's still a really new product, and in addition to working with it and trying it out, we would love your feedback. If you have ideas about features or additional functions, or like, I would be able to use this at my job if it did this thing, then, you know, all of that is really useful to us. So we're eager to get any thoughts and ideas you have about the future of Hypar.
Definitely do it. Thank you very much. Thank you very much for the session.
Thank you.
Hey, thank you very much. Okay, so now it's time to end. We really love this session. Thank you for taking your time in the morning at 7 a.m.
My pleasure.
We will keep in touch, and maybe for the next time in Tokyo, we will gathering and try out Hypar, Code, C#, Grasshopper, whatever we want to try, the hackathon or meeting. So yeah, please wait our update.
Sounds good. Great.
Yeah. Thank you very much.
Right.
And
yeah,
have a good day. And
Thanks.
thank you very
Have
much
a good
for
night.
this great session. Thank you very much. ありがとうございました。
Bye, everyone.
Bye.